Good morning, students. Today is day 17. The chapter is derivative and the concept is higher order derivative. Now we discuss some examples related to the higher order derivative. Here is the first question. Y equals to e raised to power m sin inverse x. We have to prove that the value of this equation equals to 0. So, solution. So y equals to e m sin inverse x. Now differentiate this with respect to x, the derivative of y dy by dx. Now the derivative of exponential function is same. After that, the derivative of power m is constant and the derivative of sin inverse x is 1 upon root 1 minus x square. Now yesterday we discussed that whenever there is a denominator in the first derivative, we shift that denominator to left side. So root 1 minus x square dy by dx equals to m, but this is the value of y, so put the value y instead of e raised to power m sin inverse x. Now to eliminate this root, so squaring on both sides, so this becomes 1 minus x square dy upon dx square m square y square. Again differentiate with respect to x. Now we have to differentiate this equation. Now there are two terms. We use product rule. Product rule means first term is same, the derivative of second. The derivative of second is 2 dy by dx. After that, the derivative of dy by dx is d square y upon dx square plus second term same, the derivative of first term minus 2x, which is equals to m square is constant. We can't use product rule because m square is a constant and derivative of y square is 2y dy by dx. Now from the left side we take 2 dy by dx as a common. So 2 dy by dx as a common. We left with 1 minus x square d square y upon dx square minus plus minus minus. So x dy by dx equals to m square 2y dy by dx. So 2 cancel, dy by dx cancel. So we left with 1 minus x square d square y upon dx square minus x dy by dx minus m square y equals to 0. So in this way we can solve the equation. We can prove 1 minus x square d square y by dx square minus x dy by dx minus m square y equals to 0. Now shift to the next question. So the next question is, now shift to the second question. Second question is y equals to x plus root x square plus 1 whole raised to power n. We have to prove the value of this equation equals to 0. So solution, y equals to x plus root x square plus 1 whole raised to power n. So differentiate with respect to x. So first of all, the derivative of power n, x plus root x square plus 1 whole raised to power n minus 1. After then, the derivative of this. So derivative of x is 1. The derivative of root x square plus 1 is 1 upon root x square plus 1 into 2x. So 2 cancel. So dy upon dx equals to n x plus root x square plus 1 whole raised to power n minus 1. Now we will take LCM. This becomes root x square plus 1 plus x. Now dy upon dx equals to n. Now the base is same. We add the powers. So x plus root x square plus 1 n minus 1 plus 1, it becomes n upon root x square plus 1. Now shift this denominator to left side, and the value of this equation is y. Again, to eliminate root, squaring on both sides. So this becomes x square plus 1 dy beta dx square equals to n square y square. So differentiate with respect to x. Again, we use product rule. Product rule means the first term same, the derivative of second. The derivative of second is this, plus second term same, the derivative of first equals to n square. N square is constant. The derivative of y is 2y dy beta dx. So now we take common from these two terms. The common terms are 2 dy beta dx. So we left with x square plus 1 d square y upon dx square plus x dy beta dx equals to x square 2y dy beta dx. So 2 cancel, dy beta cancel. So the final answer is x square plus 1 d square y upon dx square plus x dy beta dx minus n square y equals to 0. Shift this n square y to left side. So this is a solution of this equation. Now we shift to the next question. Question number 3rd. So the question number 3rd, very important question. Y equals to cosecant inverse x. Then show that x square minus 1 d square y upon dx square plus x square dy beta dx plus x square minus 1 dy beta dx equals to 0. So the question is y equals to cosecant inverse x. Now solution, y equals to cosecant inverse x. Now the derivative of cosecant inverse x, remember the derivative is x root x square minus 1. So this is the derivative of cosecant inverse x. Now shift this to left side equals to minus 1. Again to eliminate eliminate root, we scaling on both sides. So this becomes x square, this becomes x square minus 1, this becomes dy beta dx whole square equals to 1. Now 3 terms. Again we use product rule. How can we use product rule when there are 3 terms? So first 2 terms same. The derivative of third 2 dy beta dx. After the derivative of dy beta dx is d square y upon dx square plus now first and third term same. The derivative of second 2x plus now second and third term same. The the derivative of first equals to the derivative of 1 is 0. Now we can see the common terms. The common terms are 2 dy beta dx. 2 dy beta dx. And common is x. 2x dy beta dx. So we left with x square minus 1 d square y upon d x square plus again 2x dy beta dx common. So we left with x square dy beta dx plus again 2x dy beta dx common. So we left with x square minus 1 dy beta dx equals to 0. So when we shift this term to right side, so the value of this equation becomes 0. So in this way we can solve the given equation and we can find the value of given equation equals to 0. The question is y equals to cosecant inverse x. The derivative of cosecant inverse x is 1 minus 1 upon x root x square minus 1. Shift the denominator to left side. So when we shift the denominator to left side, there is a root. To eliminate this root, we square on both sides. So there now we have 3 terms in multiplication. So we use product rule. The first two terms same, the derivative of third plus first and third term same, the derivative of second plus second and third term same, the derivative of first. So the question number 4. So the question number 4 is 6th question. Y equals to a cos inverse x. Then show that 1 minus x square d square y upon dx square minus x dy beta dx minus a square y equals to 0. So again question number 4. So y solution, y equals to a cos inverse x. So the derivative of y dy beta dx, we know the derivative of exponential function is same. After that the derivative of power is constant. The derivative of cos inverse x is minus 1 upon root 1 minus x squared. So this is the first step. The second step is shift the denominator to left side. 1 minus x square dy beta dx equals to minus a. The value of this equation is y. So again the third step, same step. To eliminate root, we squaring on both sides. So this becomes 1 minus x square dy beta dx whole square. This becomes a square y square. Again differentiate with respect to x. Now again product rule, the two terms, first term same, the derivative of second term plus second term same, the derivative of first, a square is constant, the derivative of y square is 2 dy beta dx. Now common elements, the common elements are again 2 dy beta dx. So we left with 1 minus x square d square y upon dx square. So minus x dy beta dx equals to a square 2y dy beta dx. So cancel 2 dy beta dx. So we left with 1 minus x square d square y upon dx square minus x dy beta dx. Now shift this a square y to left side. This becomes minus a square y equals to 0. So this is the end of the fourth question. Now we shift to fifth question. Very, very easy question. Fifth question. So the fifth question is x equals to log p, y equals to 1 upon p, then show that d square y upon dx square plus dy beta dx equals to 0. So the question is x equals to log p, y equals to 1 upon p. So x equals to log p, y equals to 1 upon p. First of all, we derivative x with respect to p. So 1 upon p. Now we derivative y with respect to p. The derivative of p is minus 1 by p square. In another way we can find a derivative, we can use quotient rule. Quotient rule is the square of denominator p derivative 1 minus 1 derivative p. So dy upon dv equals to the derivative of 1 is 0, 0 multiplied p is 0. So minus the derivative of p is 1. So this is the answer. Now we have to find first of all dy beta dx, dy upon dp, dx upon dp. Now what is dy upon dp? Minus 1 by p square upon 1 by p. So this cancel out. This becomes minus 1 by p. So the value of dy beta dx is minus 1 by p. Now dy upon dx equals to, what is the value of minus 1 by minus 1? What is the value of 1 upon p? Y. So dy upon dx plus y equals to 0. Again, differentiate with respect to x. Now derivative of dy beta dx is d square y upon dx square, and the derivative of y is dy upon dx equals to 0. So this is the solution of this question. The last question. So the last question is y equals to log x whole square. Prove that x square d square y upon dx square plus x dy beta dx equals to 2. So the last question, the question is y equals to log x whole square. Now differentiate with respect to x. The derivative of y is dy beta dx. The derivative of log x square. First of all, the derivative of power. After that, the derivative of log x is 1 upon x. Now shift this denominator to left side. So 2 log x. Again, differentiate with respect to x. Now two terms. First say the derivative of second second term same, the derivative of first 2, the derivative of log x is 1 over x. Now again shift this x to left side. This becomes x square plus x equals to 2. So this is the end of the concept for today.